Good day, guys. We are going to be dealing with the Gaussian elimination method itself. How do you solve Gaussian elimination method? Now, literally, I've talked about elementary row operation. So it's just much more like talking about elementary row operation, and it's just two things. After you break it down to the way we do talk about, having one straight then is zero. If you have moved on with my linear algebra process, you would have understand what I'm trying to say. So at that point, they use back substitution method to just solve your question. So, but there are some important things that we need to understand. The first thing is that you have to utilize row operation in solving the questions. How you get what I'm saying? And the first thing is that you have to rewrite the system as an augmented matrix. You should know what that means by now. Then you eliminate the x variable in row 2. How you get what I'm saying? You make sure you eliminate the x variable in row 2. Then also again, you eliminate the x variable in row 3. Don't worry, I've talked about this. Make sure you jot this thing down so as we move on with the step of calculation so that you can follow us. Now the third thing you need to do is you eliminate the y variable that is in row 3. Then we use back substitution to solve our problem. That's bringing out the last part, then solving it to get the other one. You get the other one. You get. Don't worry, we'll move on. You will understand better. Now these are some additional steps that you need to understand. There is that you make sure that you can swap two equations. If one equation requires what you need, and the other one is actually lagging behind, you can interswitch them. You can put equation 1 back to equation 2, equation 2 to equation 1. It's actually allowed. Then the second thing is that you can swap equation to make row 2 include y. Now also, whenever you want to swap equation, let's assume in the second row there is a normal x value, but in the first row there is no x value. Or let's assume the x value in the first row is like 3x, 3, and the second row has 1 as the x value. You can easily switch it, because 3 will still look much more complicated, but x as 1 is direct. Don't worry, we'll show that in examples. Then you can swap equation also to make row 2 y, because if you like it or not, the first row must include x, the second row must include y. Any other thing could be included, but make sure that y doesn't go away from there because it's very important. The third row must include z. That's applying Gaussian elimination method. So the same thing we are talking about here, that the left corner in row 1 must be included with 1. The second left corner, that's moving on with step, like I told you guys. The left corner in row 2 must include 1, and the left corner in row 3 must include 1. So let's look at the examples and what or how these steps could help us to deal with some certain particular problems. Alright, so here we are. And at this point, we write them in the augmented matrix form first. So we have this. Now if you are to look at this now, you see that this doesn't have s1. That means s1 is 0. Our x2 is 1 coefficient. Our x3 also takes 1, negative 2 as our x4. Then you have this as negative 3. Now for our, what do they call it? For the second row, you have 1, you have 2, you have negative 1. You don't have row 4, so that is 0. Then that is equal to the constant 2. So at this point again, we have 2, we have 4, we have 1, we have negative 3, we have negative 2. And then we have 1, we have negative 4, we have negative 7, we have negative 1, and we have negative 19. So at this point, we could brace this into bracket like this. Then this is where the work starts. Now, we have been told that no matter whatever you are doing, you must, after you put this thing down somewhere, those laws, you must make sure that you have to include the left corner of x there. And it says that you have to make sure you swap equations to make sure that in row 1 there is x. Now look at this point now. In row 1, x has been moved away there. Why do I tell you is that you see this x, y, and stuffs is just like they looking much more like x for x1, y for x2, z for x3, then another alphabet. Are you getting the logic? So it's just like a clear etymology. Just like you're saying, make sure that in this first row, s1 is present there. And as you can see, there is no s1. So we can quickly do what? A quick switch. Right? And from there, we move on. So we can say we switch equation 2 to 1, then equation 1 to 2, which we can now write like this. Then you have 1 to negative 1. Then you have 2. So you have 0, 1, oh sorry. So So you have 1, 2, negative 1, 0, then we have 2. So we have 0, 1, 1, negative 2, then we have negative 3. So you have 2, 4, 1, negative 3, negative 2. Then we have 1, negative 4, negative 7, negative 1, then negative 19. Now, if you look at this now, this is much more convenient. So what was our rule, and what is the importance of the rule? The rule tells us that we can easily interchange, and we should have done that already. We interchange row 2 to row 1. Now, what's the first step? It tells us that eliminate x variable in what? In row 2. Now, if you have to look at it now, what is the x variable in row 2? Just like you saying eliminate x1. Are you get what I'm saying? And if you look at now, automatically row 2, the x variable has been eliminated because there is no x variable again anymore. Let me just put it that way. So what was the second thing that you have to eliminate x variable also in row 3. Now at that point again, we also need to eliminate the x variable in what? Row 3. Are you get what I'm saying? So how do we eliminate the x variable in row 3? How do we do that? That is what we are thinking of now. Then we have to find a way. Now from here, the operation should be under row 3. Are you with me? So how do we tend to do that? Now, if you have to think of, like I told you, you can think drastically, but if you want to think, make sure that your mindset is fixed. It's whatever you are planning out. Now if I'm to multiply row 2 times row 1, then I subtract it from row 2. Literally, this could become 0 automatically. Then from that point now, I can say 2 times row 1 minus row 3. And that will give me what? So at this point, 2 times. Now, do not forget, why do we include this? That nothing happens to row 1. It's not affecting it. Whatever is here is what it wants to affect. So we still have our row 1 as 1, 2, negative 1, 0, then 2. Then we have row 2 as 0, 1, 1, negative 2, then negative 3. So at this point, 2 times row 1, are you with me? That becomes 2. Then 2 minus 2, you have 0. 2 times 2, 4. 4 minus 4, you have 0. Are you with me? Don't forget 2 times 2, you have 4 minus 4, you have 0. 2 times minus 1, you have minus 2. Minus 2 minus 1, you have minus 3. Then 2 times 0, you have 0. 0 minus 3. That will give you what? A positive 3. Then 2 times 2, that gives you 4. 4 minus 2. That becomes 4 plus 2. And that gives us 6. Right? So at that point, we have 1, negative 4, negative 7, negative 1, and negative 19. So we've tried as much as possible to work with the laws. So what does the second law tell us? It says that you make sure that after that you eliminate the y variable in row 3. Now if you have to look at, we didn't just eliminate the what? The x1 variable alone in row 3. We were able to manage to eliminate what? The y variable also, which means some works are moving with the way we actually wanted it to be. How you get what I'm saying? So the next step tells us that then you have to make sure that you swap equations, you try as much as possible to make each left corners 1. What do I mean? That is, I need to make the corners here, I need to make them 1. 1, 1, 1, the left corners. You know, this is for equation. Then next thing is that I make sure that this corner here turns 0. Are you with me? So, but literally what I'm working towards now is much more finding a way to break this 3 down and have a single answer, so that I can use substitution to what? To find my way. So how do I tend to do that now? Now I have to look at how to make everything here disappears. Let's look at it step by step. Now I'm going to perform an operation under row 4. under row 4 now, because I need to make all this turns to 0 also to have a single equation. Literally most cases to utilize substitution, and you can literally turn 2 to 0. If these two are working along, you can still apply a simultaneous linear equation to solve your work. So under the row 4 now, we could say that row 1 minus row 4, we should still get something out of that, minus row 4. So we have this 1 minus 1. So 1 doesn't change this, do not forget. Then we have on 2. Then we have 0, 1, 1, negative 2, negative 3, 0, 0, negative 3, 3, then 6. So 1 minus 1, that gives us 0. 2 minus 4, that gives us 6. Are you with me? And negative 1 minus 7. So that gives us negative 1 plus 7, which gives us 6. Are you getting what I'm saying? Then 0 minus 1, that gives us a positive 1. 2 minus 19. That is minus cancelled out, minus you have 2 plus 19, which gives us 21. Are we there? So at this point again, we have to think extensively. We are finding a way to break this out. So we think of how do we make this also becomes 0. Are you getting what I'm saying? So we think of how do we make this also becomes 0. And if I'm to think extensively, we are still dealing with our operation under row 4. Now, why the expression could not hit it directly straight away to get our answer was because we are not only dealing with x, y, and z, we are dealing much more extensive, but it's still like the same step that is applicable to it. So at this point now, under row 4, we have to think extensively that what do we need to do? We need to make this also 0, we need to make this also 0, so that we can have a single answer, then use it to substitute. And look here, at that point, you should know that there should not be an ambiguous statement. The moment this one is a single 1 here, we need to have, you can have a single 1 and y, you can have a single x, a single x4, x3, and you can have x2, trust me. But the moment you have x4, x3, and x2, if you get the answer for x4, this won't still work. I hope you get what I'm saying. So we have to make sure you find a way. The moment we keep working on whatever has to be left here must only be 2 expressions. 1 expression, 2 expression, 3 expression, then 4 expression or anything. But literally this cannot be 3. So you have 2 works being killed. You get the answer to one, then you get the solution to the other one. How you get what I'm saying? Or you can literally have two being killed in any part. Then you equate both of them together to get your answer. Now, from this point now, if you have to look at, we can say, let's look at the one that is faster. If you look at it, but I can utilize this also. 3 times 2, you have 6. Then 6 minus 6 becomes 0. But it will still slow my work down. Because until this 6 minus 0, that will become 6 back. But to look at row 2 won't slow my work. Why? Is that you want to multiply row 2 by 6. 6 times row 2. This requires thinking, literally, just thinking. You don't just pump into things and start solving it. You have to think very well while applying them. So 6 times row 2 now, then minus row 3. So I should be having, it doesn't affect this, 1, 2, negative 1, 0, then 2. Then I have 0, 1, 1, negative 2, then negative 3. So I have a 0, 0, negative 3, then 3, then 6. So from that point, 6 times row 2. 6 times 0, that gives us 0. 0 minus 0, we still have our 0. 6 times 1, you have 6. 6 minus 6, that gives us 0. Are you with me? Then 6 times negative 3, that gives us negative 18. Negative 18. Then 6 times row 2 rather, that gives us 6. So 6 minus 6, this still gives us 0. Do not forget. So 6 times negative 2, that gives us negative 12. The negative 12 minus 1, that gives us minus 13. Then 6 times negative 3, that gives us negative 18, right? So negative 18 minus 21, so that should give us negative 39. Are you with me? So at this point now, you should see that we're actually close to our destination already. But we just want to make sure that whatever we have here is a single one, so that you can get the answer directly. From here, I can get my answer. You know, this should be 13, negative 13x4 equals to negative 39. But just to make the final breakdown, how can we do that? We are almost close to our workout already. So at this point, sorry, I'm getting to first up. So at this point from here, let's wipe this work off. So at this point from here, we could just easily say that under row 3, we could say multiply row 3, let's say 1 over 13 times row 3. You can say negative 1 over 13 times row 3. Are you with me? So at that point, nothing changes. You still have 1, 2, negative 1, 0. Then you have your 2. Then you have 0. You have 1. You have 1, negative 2. You have your negative 3. 0, then 0, negative 3, 3. Then you have your 6. So we have 0 because negative 1 over 13 times 0 is still 0. Times everything, then you have 0, 0. So negative 13 times negative 1 over 3. 1 over 13, that will be negative 1 over 13 times negative 13. This cancels out, and that becomes what? 1. Are you with me? So then that point, negative 1 over 13 times negative 39. Are you with me? So 39 in 13, that gives us, so you have 39, that gives us 3. Minus cancel minus, so you have going to be adding 3 here. And then don't forget, this is just like x1, like I said, this is x2, this is x3, and this is what? X4. So directly now we could see that we have x4 equals to the constant, which is what? 3. So from this point, like I said, we start utilizing back substitution. That is moving from the back, then you going upward. So from there, we should know that the expression from there, S4 will be equals to 3. And from this one, you should know this equation 2 here. This is negative 3x3 plus 3x4 equals to 6. Right? Then from there, we have our x4. That means negative 3x3 plus 3 into bracket 3 will be equals to 6. So we have negative 3x3 equals to 6 minus 9. Then negative 3x3 would be equals to negative 3. This cancels out this. This cancels out this. So x3 would be equals to 1. Are you with me? So at that point, we have our x3 being equals to 1. Then moving on again to the next one. So we have gotten our that. So from the that's why they call it back substitution. So from here, we have x2 plus x3 minus minus 2 x4. That's the third point here, equals to negative 3. We've gotten x3, we've gotten x4. So x2 plus 1 minus 2 into bracket 3 will be equals to 3. So we have x2 plus 1 minus 6 equals to 3. So we have x2 being equals to 3, then plus 5, which is equals to 8. So that shows that our x2 is equals to what? 8. Are you get what I'm saying? So at that very good point, so our x2, let's check out very well. This is x2 plus x3, right? So x3 is 1. And we've gotten our x4 being 3, our x3 being 1. So we have to check this out. You have negative 6, 1. This will give you negative 5. Then negative 5, then this you have, okay, sorry, this is negative 3 here. Sorry. So at that point, you have x2 being equals to negative 3 plus 5, and that will be equals to 2. So our x2 is actually 2, not 8. So from there, the last operation, you have x1 plus 2x2 minus x3 equals to 2. There's no x4 there. So x1 plus 2 into brackets 2 minus 1 equals to 2. So you have x1 plus 4 minus 1 equals to 2. So we have x1 being equals to 4 minus 1, you have 3. Going back here, that will be 2 minus 3, and that will give you negative 1. Which means our x1 is equals to negative 1. So that is how, what do they call it? This guy works. which is the gas elimination method. So you can actually use it to express one or two much more important then. Please try to like and subscribe. Thank you.